Simplify the following square root. So when you're simplifying a square root, there's several things you need to know before you get started. For one, you have to know what perfect squares are. So here's a sample list of the perfect squares: 4, 9, 16, 25, 36. And these ellipses, or these three dots, means that that list continues. So there's no end to it. I could keep going higher and higher if I want. So I'm not going to do that, but I can show you how to produce this list because that's important. So how did I get 4, 9, 16, 25, 36? Well, 4 is the result of multiplying 2 times 2. 9 was the result of multiplying 3 times 3. 16 is the result of multiplying 4 times 4. 25 is the result of multiplying 5 times 5. 36 is the result of multiplying 6 times 6. And that list goes on and on. So a perfect square is the result of taking a number, multiplying it with itself, and that result is a perfect square. So to be clear, 3 is not a perfect square, but if I take 3 and multiply it with itself, I get 9, and 9 is a perfect square. So it's the result of after the fact that you multiplied it with itself. Those are the perfect squares. So that's one thing to keep in mind. And the other thing to think about is the idea behind simplifying a square root. So simplifying a square root is almost like reducing fractions. So what do I mean by that? Well, if you have a fraction, let's say 9/12. So when you simplify a fraction, you're trying to see, eliminate any of the common factors. So I know I could rewrite 3 or 9 as the product of 3 times 3. And I know 12 is the same thing as 3 times 4. So they have a common factor, which is 3, because 3 goes into both of these numbers. Now, I can reduce this, so I get 1 times 3 over 1 times 4, and that result is 3/4. So I can see here that 9/12 is equal to 3/4. So they look different, but they have the exact same value. If I were to go and divide it, I would get 0.75 or 75 hundredths. Alright, so the idea with reducing fractions is you basically end up with the same value, it's just in reduced form. Well, when you simplify a square root, it's the same exact idea, where your final answer is going to have the same value as the original, except that it's in your reduced form, or in terms of a square root, we call it simplifying. So if I look at simplifying this square root of 45, you're going to think about those perfect squares, and you want to say which one of these perfect squares is a factor of 45. So which one of these numbers can I rewrite 45 as the product of one of these and another number? So if you go through your list, you can use a calculator if you want, and you can just say, okay, well, let me do 45 divided by 4, and I can see that that number is a decimal value, so I know that it doesn't divide into, it's not a factor of 45. If you get a decimal, it's not a factor. And then I go to the next number in the list, 45 divided by 9. I get an integer, so I know that 9 is a factor of 45. So I can use that number. So I'm going to rewrite this as 45 is the same thing as the product of 9 and 5. And when you're simplifying square roots, you want one of the factors to be a perfect square. So that's why it helps to have the list handy somewhere. One of the rules when you write a square root, or a product inside of a square root, is you could split that product up. So I have the square root of 9 times the square root of 5. So if you have a product that you're taking the square root of, you could write it as the product of the square roots. So one way you could think of it as just splitting it up. So these are equivalent. And now we have the square root of 9. When you're asked what's a square root, you're basically saying what number times itself gives you, 9. Well, I know it's a perfect square, and the way I got 9 was 3 times 3. So the square root of 9 is 3. And one thing to be careful of is a common mistake I see is the square root of 9, people put square root of 3 after, but that would be incorrect. right? The square root of 9 is simply 3, because 3 times 3 gives me back 9. And then I bring back the remaining 3 times the square root of 5, and then I ask myself again, is there any perfect square that divides into here, the 5? And in geometry we call this the radicand. So do any of these divide into the radicand? And I can see that none of these are factors of 5, so this is considered to be simplified.